Alright, so as we get going, please make sure your plan book is filled in. I need to change my plan book wall. But then, unless you're like a fantastic artist at drawing straight lines, you're going to need a ruler, so you should grab one of those. No, and you don't even have your assignment written down. Maybe somebody should do a discovery day of making seat cushions so that we have seat cushions. Hey Nick, I'm going to need to ask you to stop there. Alright, so let's have a chat while you're getting started up. Our header today is scaling graph axes. Remember, 1 is an axis, 2 are axes when we make it plural. What sort of things do we think about when it comes to scaling axes? Like, how do we choose what to do? Nikki, did you see your blue sheet was back there? Did you see that your Discovery Day blue sheet was back there? Okay, just making sure, because you shouldn't have it sitting around not in a binder, and it made me worried. Made me scared. When we scale axes, nothing? When we scale axes, what do we think about? So, anyone ever hang out outside at night and you see what you think might be birds? You're like, that doesn't make sense. Birds sleep at night. Yeah. And you realize, oh, those are bats. Yeah. Ooh, I don't want to show you that yet. I love bats.
Really?
Yeah, they're cool, and they eat mosquitoes and stuff like that.
There's one that flew like right past that.
Yeah. So the bats that we have in Ohio are fruit bats, pretty much mainly. Hey, do me a favor and don't make me move you today. Okay? Please and thank you. Because if you're done with your plan book, you can put it away. And I don't know where your graph paper is. And that graph paper that you don't have out is supposed to have a header on it, and those things. So don't make me move you today. So when we think about graphing data, and we're going to graph some data involving bats, we got to think about, like, does our data fit? And, well, if we're making the graph, we can make it fit. How can we make the graph clear or, like, better? Right? Like, what's the best way to make the graph? What's the best way to scale it? How can we use that graph to make a prediction? This is really why I love what we're about to do, because when we can, like, make predictions or tell the future, that's pretty awesome. And can we make a different choice to make things easier? So, Peyton also loves bats. Right? Peyton loved bats so much, she took a discovery day to Tennessee and collected some data, did some research on bats. I don't know what a bat researcher would be called, but there's probably a cool name for bat researchers. Ornography is like the study of birds, but I don't know about bats. So we have this data. Real quick, let's copy this down. But we'll abbreviate things. So for like big brown bat, abbreviate that like BBB. Right, let's copy down this data just so you have it for quick reference on your paper. So make a quick little T chart, but it'll be a double T chart because we'll have two T's next to each other. I'm going to throw this data down here. We're going to copy this data over. So it's down on the bottom TV, but I will copy it up here. So the big brown bat. Right? Length of 5 inches. And wingspan. You know humans have wingspans? Yeah. Even though we don't have wings? Yeah. Your wingspan is how wide your arms stretch in totality. And 14. That wasn't your permission to talk, because I doubt your table's done. Little brown bat, LBB, is 3.5 and 10. Bing, bing, bong.
Yes. That person goes up. That one show called
Brazilian three-tailed bat. I'm going to call him Braz. Because he's the only Brazilian bat we have there. 4.25 and 12. Evening bat. I'll call her Eve. 4 and 11. No, it's a her.
How do you know?
I met her. She's very nice. Indiana bat. I'm gonna call him Jones.
Are you gender? Ew.
No, I met them.
I can't even look at you.
Indiana bat. If you don't know why I'm calling that bat Jones, that's your own problem.
Then you are not worthy.
So we're gonna try to graph this data. We want to draw an X and a Y axis. And who can remind me, actually we'll make this like worth the prize for today. Who can remind me what we talked about last week about X, Y axes and like how we talk about the variables? One is different than the other. Savannah?
Take your heart
I ate breakfast though. Ah, that didn't work.
What did you say about axes?
Yeah, what did I say about axes, Toby? Do you know? What did I say? Well, I know, but that's not what I said about axes. So the problem is I turned that alarm off over the weekend so I could sleep if my dog's left. X, Y axes. So everybody draw X, Y axes on here.
Yes, sir.
Well, that's for us to figure out. So I'm not telling you yet how tall, but we're trying to remind ourselves what we say about these axes. Bella, do you remember what we said about these axes? Which one does what and why? How we decide what goes where? Ooh, independent. Which one of these is independent versus which one of these is dependent? The y-axis is dependent. And the x-axis, sorry, that's an I, just went a little rogue, independent. So the question we have to ask ourselves here, what depends on what? Right? When we look at the data we have, what depends on what? Will length of the bat's body depend on the wingspan, or will the wingspan that the bat has depend on the length? Well, I'm not a bat professional, but I have to think that just like humans, your wingspan gets bigger as you get taller. The wingspan depends on the length. So we're going to call this our X and this our Y. So now we should be a bit more informed to be able to make a graph of this data. I want you to show the scale of your graph, right? Give it numbers on the axes and plot these 5 points. Because realize your Y's go way bigger than your X's. That's why I'm telling you to give numbers to your graph so you know what's what. Even if you make your boxes 1, 1, like 1 over is 1 and 1 up is 1, you still want to label that. If you can't remember independent and dependent, you might jot that down right now as well. I don't know. We'll find out next period, I guess. You got a graph. That time's not quite accurate. Oh yeah, it is. So Peyton shows us this graph. What do we notice here? Just observations. There's no like right, wrong here. Anybody have any observations? Eric?
It's like one of the dot graphs and not like a bar graph?
Yeah, it's a graph plots graph, right? So we're plotting points as opposed to making a different type of graph, like a bar graph. So, did you interpret that we were going to make a bar graph? Ah, interesting. So we are making, like, plotting points. Okay, so flip your page or something. You don't have to erase that. Like, don't spend your time erasing that. But flip your page, and I would say get X, Y axes on. Plot this. Now, this is kind of my fault, because in science, you guys have been talking about graphs, and you've been using different types of graphs. Some of them, you know, are bar graphs. Some of them are histograms. Yeah. I've seen a lot of different types of graphs come across. Toby?
I noticed that the bigger the number of the length.
Ooh, so these kind of vary together. The bigger the length, the bigger the wingspan will be. So as X goes up, it doesn't just like go over, right? We don't have points that just go across. They go up to the right and up. To the right and up, and then to the right and up. Interesting. There's only one occurrence of X just getting bigger, which if we look back at our data, that would be the same wingspan, right? This Y value and this Y value, and this 3.5 and this 3. Those are those points that are right beside each other. Aside from that, everything does go up together. Anyone kind of not like the giant gap that exists right here? It's like there's a bunch of my paper I didn't need to use on this graph. So what if we changed our axes? Go ahead and draw another set of XY axes, but we're going to do it smaller this time, because instead of each X being worth 1, like we did right here, or sorry, that's Y. Instead of each Y being worth 1, we're going to make each Y worth 2. Now keep the X's worth 1. So this will still be worth 1, but this one, we're going to change it to be worth 2. Take a moment to do that. I don't want to show it to you before you have a chance to do it. Did you already do it that way? Ah, so there's only one issue that you have here. You have to break it. So if you want to jump and then start a different scale. So when we're working on graphics, we want to make sure that we follow the boxes. So line up on the line. See how this is off, that's off. So, but if we want to break the graph, we draw a symbol like that. So we would actually erase part of the vertical. It's kind of like a Harry Potter lightning bolt in a way. Well, I'm being serious. So what Molly just asked about, totally worth talking about. Molly noticed that none of our values started before 10. So Molly just said, okay, I'm going to start with 10, but then I'm going to go 1 each. You do not have to do this. I am just showing you something. Give me your eyes up here real quick. If Molly wanted to do this, and we know that this intersection, this middle point is 0, 0, right? Always. It can't not be. But Molly wants to just jump up to 10 and then go by 1. There's a way she can do this. And how we do it is in a technique where we call breaking the graph. So what we do is we literally cut the graph and imagine if blank. We are using these. Imagine if this is the y-axis. You are effectively doing that with the y-axis. So how we show that mathematically, it's all compressed down onto itself. So imagine literally if we took the y-axis and like just squeezed it into itself, we just draw a little lightning bolt, and that shows we compressed a section of the axis. We don't care about it. Yeah, there's nothing there. And then Molly was able to show the data that we had. Now, if we go with the y-axis being 2 for each of them, now wait a minute. This is the graph that one of your classmates made. Is this correct? With what I asked you guys to do, and that's why I gave you a head start. This is what a classmate did, right? A made-up classmate. What axis did they change? They changed their x Do they have their X and Y axes labeled? No. So this is my roadblock, like stop point. If you look down at your paper and you don't have an X on the X-axis and a Y on the Y-axis, kind of give yourself a little like I don't know, finger wag or something. Like no. You have to label your axes, X and Y. Now, technically, once you get like, you turn into a professional grapher, do you really have to label them? No, but right now we're going to, so that our brains have an easier time of remembering. Oh yeah, that's the X, that's the Y. They should have changed the scale over here, not the scale down here. Now, why wouldn't we change the scale down here? Why doesn't that make sense when this was the graph that we started with?
Excuse me, I'm sorry for the interruption. I need Dana Baker to the office, please. Dana,
Okay.
come to the office.
That's all the numbers for X are under 5.
Yeah, all the numbers for X are under 5. We don't need to go up to 40. We don't even need to go to 20. We don't really need to go to like 10 for my X's. Now my Y, we need to go higher up, but if I make this turn into 2, what we'll still notice is all of these points on your paper, if you plot them again on that new graph, they're tighter together, right? They compress down into each other. They stay the same width because we kept the X-axis the same, but please graph those points, and that's why I had you write them down, but these points, please graph those on your new graph. Now, is that better? Molly kind of let the cat out of the bag today. Which, if there's ever a cat in the bag, please do let the cat out. Like, that expression always weirded me out. So I was like, who put the cat in the bag? Hey, don't tell me that. That makes me feel like I work with interesting people. Oh my gosh, on the New York City subway, they created, yes, we're going to be off topic for a moment. They created a law that said you can only have your dog on the subway with you if it fits in a bag. So what people notoriously did was get the biggest bags possible. And there are the most adorable pictures of very large dogs in bags. It is quite fun. I'll try to pull them up at the end of class if we get through everything. Toby? Yeah. A raccoon?
People like,
That's a bad idea. That's an inherently wild animal.
squirrels and like
Well, that's
raccoons
different. Take
when
them to an
they're
animal restaurant.
when they're little, and then they just keep them.
They said that
They
very
bring them.
angrily.
They bring them to the bed, and then they get them fixed, but then they just like raise them as their bed, and then they're raccoons.
All right, what I'm hoping you notice about that graph you just made, it's kind of better. It leaves less gap, but that's not the best, right? So, like you said, Molly kind of let this, the secret of my lesson out. The best way to make this graph is to compress down, but not like compress your scale, right? Because that just makes your points tighter together. The best way is to break your graph. So make one more set of XY axes, but we're going to break this Y axis. So right in the first box, put a lightning bolt. So make another set of XY axes, but in the first box, you're going to split that Y axis, put a lightning bolt. We're going to start at 10. Now remember, this is wingspan. Yeah, we're making another one. That's why I said one more. If you already drew the broken graph on your paper, obviously you don't need to draw another one. But back when I was showing that, I said you didn't have to, because we weren't quite there yet. I wanted to do the not awesome one first, and then we'll get to the Molly awesomeness. So then, question though, with my x-axis, we've been doing scaling by 1, but we just talked about how we don't need to go up to 10, we don't need to go up to 20. Anybody have an idea of what I can make each box worth to like spread things out? Yeah, Morgan? Make each box worth 2 or make 2 boxes worth 1? Like, do you want me to do this as 2, 4? Like, do I need to go higher? With our length. So if you look back at the table that we... The length doesn't go very high, does it? Zach, what do you think? Yeah, make each box worth a half and spread things out more. So you don't even have to write the 1/2. Just put a 1 right here at the second box. So guys, here's what I really want you to see on this slide. So give me your eyes for a second. Your options when defining the scale of your graph are show it on the first box. And then if this graph wasn't broken, what would this next box have to be? If this wasn't there and the graph wasn't broken, that next box would have to be 20, right? Because the scale has been chosen. But since we broke the graph, we can make this like bold, 10, 11, 12. We're allowed to do that since we broke the graph. We took some liberties. So you can show it on the first box or show the first 1. Right? You could actually make 3 boxes worth 1. And then each box is worth a third, but you don't have to label the thirds. Right? You could do this if you really want to spread your data out. You do 2, 3, 4, 5. Notice how that nicely uses up most of the width that I have here. So here's my actual, here's the trick. So please on your paper write down choosing scale. How we choose the scale is the amount of boxes, the amount of boxes we have available. So some kids will just say, well, I counted my paper once and I know how big my paper is. Like, well, that's great, but we don't always use the whole paper. So however many boxes you make, right, when you make the X, Y axis, as I walk around the room, each of you makes it kind of different. But the one thing I told a couple of you is use that ruler, get your lines on the boxes so that you can count the boxes. And then we divide that. I'm going to make sure I'm not going to knock this thing off. Count the boxes, or counted boxes, divided by the number we need to go to. So like the max value that we're working with. Now, all of this can be rounded to make your life easy. Right? So what I mean by the boxes divided by the max value, if I go back here and I count my boxes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I have 20 boxes. And the number that I want to get to based off the table that I have, what's the highest X value that we worked with? Get out of here. 5. Right? My max X that I need to work with is 5. So I do 20 divided by 5. And actually the most efficient scale I could have chosen would be that 4 boxes is 1, what were we talking about, inches? Because this is boxes over inches. That answer comes out to be 4 boxes is 1 inch. Now, I made 3, and that's why I had leftover. Right? That's why I had leftover space out here. So we're going to practice this, because I know right now, especially with the looks on faces, I see that it's like, okay, I'm listening, but I don't quite understand it. Debating if we want to start your homework and help you with that or not. So I know you guys were doing this in science. What is something that somebody researched and found data on? Araya, what'd you do?
I researched
Ooh. Yeah, that I'm trying to think of how we could. Let's say that this is the data that we've been given, because I like real world situation. If it will ever paste. Yeah, I don't know if that image is actually going to... Oh, that's worse.
Oh, God.
Hey.
Can this thing hear my voice? Like the TV?
Recording? Yeah.
It can hear me?
I mean, if you speak up enough and if other people aren't talking.
Hello! Send help. No.
Nick, as funny as you might think that is, it's not really funny.
That could cause him to lose his job, you know.
Well, I could really just get Nick in trouble. I don't think I would get in trouble since I didn't do anything, but then again, who knows? The world's a crazy place. Sorry. Smart board is, Alright, make an XY axis however big you want.
Oh,
Well, X has to be X and Y has to be Y. Now here's the issue, and here's why I don't say you have to match me. My screen is wide. Your paper is tall, unless you're just using sections of your paper. So if I was going to graph the data that we just pulled, and I create an XY axis, first thing I'm going to do is ask myself, what am I working with? How many boxes do I have available? So here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Do you think I'm going to work with 11? No, I'm going to work with 10. Or yeah, whatever you have on your paper, that's your boxes available. So in your head, make a mental note of how many boxes you have available. Across 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I could go more than that. I can work with 12, but 10 may be my best bet. So I've got like 12 or something out here. Now, your numbers aren't necessarily going to match mine, right? You've got more boxes on your paper. If we wanted to graph this data, we're going to go ahead and say weight probably depends on height. Like maybe not. And this, we might find some interesting relationships here. So if this is XY, our lowest X is 69 and the highest, they're actually right next to each other, is 82. What's the spread between those? Not like 20, actually. 13, right? There's a 13 spread, so I need to graph at least 13 wide. What's the lowest here? 180, right? Highest is 231, right? Yeah, that spread's 51. So if we go to graph this, we'll just do one more and then we'll probably let you start your homework. Should I, and this is rogue of CPM, if I needed to get up to, well, actually, I'm going to do the CPM, like what they would want us to do. My highest value here is 82. And if I don't break my graph, right, if I don't break my graph, and I want to be able to show up to 82, I have like 12 boxes here. If I round, I have like 10 boxes here. What should I make the value of each box? If I want to make my life super easy, can I go by tens and fit my data up to 80 something? Yeah, I got plenty of space. But if you wanted to like do this most efficiently, think about I need to get up to the number 80. Right? And I have like boxes. And actually, I may have described it. So that technique of that division, I'm just realizing this as I teach it, because this is different than how I taught this last year, goes either way. Here, we wouldn't want to do 12 divided by the value of 80 that we want to get to, because that's not going to come out to be the right number. But if we flip that over and do, we need to get to 80 something, and actually we could make that number nicer, divide it by 12. Well, if we make this even nicer, 80 divided by 12 is a little weird. 80 divided by 10, what would 80 divided by, 8. I could make each of these 8, and then that will nicely go up to, I think this was my 10th box. That'll nicely go up to 80. But here's the issue. Hold on, don't write that down. All of my points will be clustered out in this region, because none of them exist below 60, right? I don't need any of that graph below almost 70. So I would only use this section. That's why we break graphs. And CPM doesn't start doing this yet, but I wanted to make sure if we're going to talk about it, we might as well actually talk about it. This would be a perfect situation where both axes would need broken. So we would break both axes. We could probably, just to make life easy, start this at 60. Right? Nothing goes below that, even close. And then the y-axis kind of nicely starts at 180. We could do 180. Both axes would have a lightning bolt on it, right? But now is when I do that math. If I want to go, I'm going to do the y-axis because it's easier to see. I want to go from 180 up to 230, really 240, right? I need to go past that point. So I need to span 60. I need 60 in here. Well, now we count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 if I go all the way up to here. So if I'm able to work with 10, what could each of them be worth? 6. What if I make each of them worth 5? 185, 190, 195, 200, 25, 210, 215, 220. It's not enough, right? So I either need to make each 6 or more than that. When you're choosing your scale, you got to check, will it work? Or could I extend my y-axis higher? So I'm going to try to wrap this up. So then 60 needs to go to 80. That's a span of 20 that we need to cover. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I could use all 10. I could just move where I dropped that 80. If I use all 10 boxes and I need to span 20 getting this way, what should each box be worth? 2. Because I need to span 20, I can use 10 boxes. So actually that division, depending on how you're choosing your scale, you can do the division either way. So this would be 62, 64, and you'd go from there. Your homework is a little bit stepped back from that. So it's more so, like we're going to do 115 probably a little bit together. It's more so like given these points that already exist on the graph, choose scale, go from there. So this gives you a reminder of the generic rectangle method for multiplying mixed numbers. So this was on your previous homework. You already got one today. So once I just made these today. Yeah. So because we continue practicing multiplying mixed numbers, that's why I put a reminder on here. We do a lot with the generic rectangle. Like a lot. If you want, I would go back. What slide I put it on? I would go back to here and put a little arrow that sometimes this division gets flipped. So I would put a little back and forth arrow there that sometimes that gets flipped. Alright, so notice that like in 115, it's more so they give us the values. If there's no lightning bolt, if there's no break on the graph, we know it has to cover the whole thing. So take a second, try 115, and then we'll go over it together to make sure we're comfortable. So take a moment on your own. I'd like you to try this without talking to neighbors to see if we can do it on our own. Sounds like the Jetsons. Anyone talking through how we solved A? Bella? Okay. So we wouldn't divide the two numbers that we have here with each other. I don't know, maybe you're not remembering what you did. Did you do this right now, or did you do this like a few minutes ago and then come back to it? Okay, so the technique that we follow here is we do the difference between these numbers, right? How far do we span? So to get from 32 to 64 is a distance of 32. To get there, we travel 1, 2, 3, 4 jumps. What is each jump worth? And that is 8. Like that comes out to be 8. So actually 64 divided by 32, that would have only been 2. So I'm curious how you got 8. Because it's the right answer. So this becomes 40. This becomes 48. This becomes 56. Thank you. And you should keep going above the number. A lot of you guys, when we do this on mini masteries or on the actual mastery, you stop. You're like, oh, I hit the other number. I'm done. No, keep going. 72. 80. I'm going to jump to C, because B I'm going to let you guys do on your own. That's going to come out to be either a fraction or decimal value. Right? In C, C will help you with B. Right? C will help you with B. So if you are a little confused, eyes up here, please. This gets to 1, but how many jumps does it take? 1 jump. 2 jumps. So 1 divided by the 2 jumps, oh yeah, that's a half, right? Or 0.5. Each jump, each block, each scale, whatever you want to say, is worth 0.5. How far is this gap on the x-axis? Yeah, because I saw it, and everyone was going to be like, look, typo, look. And before I made the copies this morning, I saw that, and I was like, yeah, well, I'm not going to go back and reprint it.
Can you make it find Mr. Hudson's house?
Yeah, okay. It's 3. Yeah, because it's 9 divided by the 3 jumps. So guys, the trick or the technique or the strategy with most of what CPM is going to put in front of you is what's the distance we need to cover divided by how many jumps to get there. So when the numbers have already been chosen for you, right? When we aren't choosing the numbers, when there are already numbers chosen for us, we are doing distance that we need to cover. You might want to write this down, even just on your blue sheet. I either call these jumps or gaps. Right? You don't count ticks. You actually count the gaps between them. So here, 1 gap, 2 gaps, 3 gaps to get to 12. 12 divided by 3 gaps to get there. What's each gap worth? 4. This comes out to be 4, and then 8, and then 12. Here the distance is 20. How many gaps? 5. What's each gap? Oh, these are scaled the same. They don't need to be, but they are. You got the next like 2 or 3 minutes until we leave to work on your practice. Yes. So what? Oh, sure. So we will actually graph that later this year. That's a graph that we use in CPM to show that it's not a proportional relationship. So the weird thing is, who what? So 60 inches is 5 feet. 72 is 6 feet. Yeah, that's 6 feet 10 inches. Yeah. I mean, but if this is NBA stats, like 6'10", yeah. I mean, okay, you're tall. That's not crazy tall. Like, I mean, it's pretty darn tall for normal people.
What is this?
But for NBA players, this is, I'm pretty sure this is NBA players. So, like, just 10 randomly chosen NBA players. Yeah, that'd be really tall for football. Now that weight would make sense for football.
Yeah, but
but-
they're like short but like big.
Yeah. So that weight would make sense for somebody shorter, to be like a lineman or somebody like that. We only have like a minute left, so if you want to pack up, you can.